Search for artificial intelligence trends in 2026, and you will find the usual parade of predictions. Smarter robots, fully autonomous companies, artificial general intelligence arriving any minute now. But the AI trends that actually matter are less dramatic and more practical. AI is shifting from answering questions to carrying out tasks. It can process more than text. Adoption is moving faster than organizations can adapt. And the biggest limits are increasingly found outside the model, in electricity, chips, data, permissions, and human oversight. So this is not a list of futuristic guesses. These are 6 changes already visible in the data, each with a practical consequence for how you work, learn, and judge AI systems. Trend 1 is the move from chatbots to agents. A chatbot waits for a message and produces a response. An agent is built to pursue a goal through several steps. It might search documents, open software, write code, compare results, correct an error, and continue until it reaches a stopping point. The strange part is that an agent is not necessarily a radically new kind of intelligence. The hidden mechanism is usually a language model placed inside a loop. The model observes the current situation, decides on an action, uses a tool, reads the result, and decides what to do next. Give that loop access to a browser, company files, email, payment systems, or a coding environment, and a model that once produced paragraphs can now affect the outside world. This is why agentic AI is both useful and dangerous. A hallucinated answer is bad. A hallucinated action can be worse. An agent might edit the wrong file, send incomplete information, repeat a transaction, or get trapped in a loop. Performance is improving quickly. Stanford's 2026 AI Index reports that agents rose from roughly 12% to about 66% success on OS World, a benchmark involving real computer tasks. That is a major leap, but it still means failure in roughly 1 out of 3 attempts under structured testing. The common misunderstanding is that autonomy is a switch. In reality, it is a permission ladder. An agent that drafts an email is different from one that sends it. An agent that recommends a purchase is different from one holding a credit card. The practical consequence is simple. When evaluating an AI agent, do not ask only how intelligent it is. Ask what it can access, what it can change, when it must request approval, and whether its actions can be reversed. Trend 2 is multimodal reasoning. Earlier AI products were divided into separate boxes. One model handled text, another recognized images, another transcribed audio. Multimodal systems can work across several types of information in the same task. That means you can show a model a damaged appliance, describe the sound it is making, provide the manual, and ask it to identify likely causes. Or you can give it a chart, a spreadsheet, and a written question, then ask it to explain what the numbers mean. The important word is not multimodal, it is reasoning. The system is not merely labeling what appears in an image, it is connecting evidence across formats and using those connections to produce an answer or action. Video models are especially interesting because video contains clues about how the world changes over time. Objects collide, liquids move, shadows shift, and actions create consequences. Stanford highlighted tests in which video models displayed limited abilities involving physical behavior and maze solving, even when those exact tasks were not the main training objective. But do not confuse broad input with reliable understanding. AI still has what researchers call a jagged frontier. A model can solve a highly advanced mathematics problem and then fail at something that looks embarrassingly easy. In one example, an AI system reached gold medal performance on international mathematical Olympiad problems, while the strongest model on a clock reading benchmark correctly read analog clocks only around half the time. So the practical consequence is that screenshots, voice, and video can make AI much more useful, but not automatically more trustworthy. Give it the original evidence whenever possible, then verify the answer where mistakes matter. If you like grounded explanations of AI without the magical thinking, subscribe. We are going to keep separating what these systems can actually do from what the demos make them look like they can do. Trend 3 is adoption moving faster than transformation. Google search behavior increasingly reflects a shift from asking what AI is to asking how AI can help. Searches for the best AI for coding, writing, mathematics, and image generation show that many users are no longer discovering the category. They are shopping for a practical tool. Stanford estimates that generative AI reached 53% population adoption within 3 years, faster than the personal computer or the internet. It also reports AI use in 88% of surveyed organizations, and generative AI in at least one business function at 70%. Those numbers sound like AI has already transformed the economy, but there is an important gap. The same report found that agent deployment remained in the single digits across nearly all business functions. Using an AI tool is easy. Redesigning a workflow around it is hard. A company can give every employee a writing assistant in one afternoon. It cannot instantly clean years of messy data, connect old software, decide who is responsible for errors, retrain employees, and measure whether the tool is creating real value. This is why adoption statistics can be misleading. Opening an AI application once a week counts as adoption. It does not prove that an organization has become more productive. The practical consequence for viewers is that basic access is no longer a major advantage. The advantage comes from knowing where AI fits inside a repeatable process. Choose a task with a clear input, a checkable output, and a measurable amount of time or effort. That is much more useful than trying to use AI everywhere. Trend 4 is that inference is becoming the real bottleneck. Training a model gets most of the attention because it requires enormous clusters of chips. But training happens before the product is used. Inference happens every time someone asks the finished model to do something. Think of training as building an engine. Inference is the fuel consumed every time that engine runs. A short chatbot answer may require one model call. An agent may make dozens. It plans, searches, reads, revises, checks, and tries again. Add long documents, live audio, images, or video, and the computational workload rises further. This creates a physical constraint that software hype tends to hide. AI needs chips, data centers, cooling systems, grid connections, and reliable power. Stanford reports that global AI compute capacity has grown rapidly since 2022. The United States hosts more AI data centers than any other country, while TSMC fabricates most leading AI chips. That creates concentration at several points in the supply chain. It also explains why smaller and specialized models matter. The most powerful model is often unnecessary for summarizing a form, sorting support requests, or extracting information from an invoice. A smaller model can be cheaper, faster, easier to run locally, and sometimes more predictable on a narrow task. The practical consequence is that AI products will increasingly be judged by cost per useful result, not just benchmark scores. Latency, privacy, energy use, and the number of model calls needed to complete a task are becoming core product features. Trend 5 is the widening responsible AI gap. Capabilities are advancing faster than the systems used to measure and control them. Leading developers regularly publish results for coding, mathematics, and reasoning. Reporting on safety, fairness, privacy, and transparency is far less consistent. Stanford recorded 362 documented AI incidents in 2025, up from 233 in 2024. It also found that the average score on its Foundation Model Transparency Index fell in 2025, with major gaps around training data, compute, and post-deployment impact. Responsible AI is often discussed as if it were a personality setting that makes a model polite. It is really an engineering and management problem. Who can use the system? What information can it access? Does it store personal data? Can its decisions be audited? What happens when someone deliberately attacks it? Who is accountable if a model gives the wrong answer, but a human approves it without checking? There is another complication. Safety goals can conflict. Making a model refuse more requests may reduce harmful outputs, but it can also block legitimate ones. Collecting detailed logs helps investigations, but it may create privacy risks. Hiding internal reasoning can reduce certain attacks, while making a system harder to audit. The practical consequence is that a responsible AI policy means very little without operational controls. Look for limited permissions, testing, logging, human review, clear escalation paths, and a way to shut the system down. Trend 6 is the narrowing US-China model gap. For years, the simple story was that the United States had the frontier models, while China remained far behind. That story is no longer accurate. According to Stanford's comparison from March 2026, the top US model led the top Chinese model by only 2.7%, with models from the two countries trading places during the previous year. This does not mean both ecosystems are identical. The United States still leads in private investment and produces more notable frontier models. China leads in AI publication volume, citations, patent output, and industrial robot installations. The performance gap is narrowing, partly because useful techniques spread. Research papers, open-weight models, better data filtering, distillation, post-training methods, and inference optimizations allow competitors to reproduce improvements faster than they could invent an entire model stack from zero. Chip restrictions can limit how much compute Chinese labs can access, but constraints can also create pressure to use available compute more efficiently. Chinese labs have also leaned heavily into open-weight releases, allowing developers around the world to download, modify, and host their models. Still, benchmark convergence is not the same as complete equality. Models differ in reliability, languages, censorship behavior, security, tool use, price, and access to computing infrastructure. Even the benchmarks themselves can contain flawed questions or reward systems optimized specifically for the test. The practical consequence is that the AI competition will not be decided by one leaderboard. It will also be decided by which models are affordable, trusted, customizable, widely distributed, and useful in local markets. Put these 6 trends together, and the real story of AI in 2026 becomes clearer. The models are becoming more capable, but the center of gravity is moving toward systems. Tools, workflows, infrastructure, permissions, and distribution now matter as much as raw intelligence. The smartest model does not automatically create the best outcome. The winner is often the system that completes a useful task reliably at an acceptable cost while keeping humans in control of the decisions that matter. Which of these trends should we unpack next? Leave your questions and topic suggestions in the comments.